by SSS theorem. So this is by SSS theorem, is by side similarity theorem. So this ratio, let me see, by SSS theorem, then HL over JL is equal to IL over KL is equal to what ratio? So let me draw out the true triangles for you. And I think they drew it out as well. And I'll show you how they drew it out. So I'm going to do this in blue. So let's do, so I have a triangle like this, and a triangle like this. This is K, J, L, and this is L, I, and H. Okay, so you have here your triangle. And it's here, so let me denote this in red. It says HL, so that's this point to this point, from here to here, is similar to JL, or it's proportional, right? It's proportional to JL, which is great. And IL is from here to here, is similar to KL. So what other ratio can we write here by SSS theorem to prove that these two triangles are similar? So let me give you a minute to think about this question. We might have to define SSS theorem for us to figure this out. But if you know it, again, if you're here in the chat, let me know by waving hi or just answering the question itself. But let me know what your thoughts are on this question. So how do we use SSS theorem? Or first of all, what is SSS theorem? Second of all, how do we use this theorem to write down another ratio to prove that these two triangles, so HLI and JKL, are indeed similar? Sorry, this is JLK. Let me, the order kind of bad. There we go. So let's take a minute to think about this problem here. So what we have is we have a SSS theorem, right? And by SSS theorem, that states that two triangles are similar. So let me write down the theorem here. So it states that I'll say two triangles. This is my short form from triangles, are similar if all three pairs of sides are equal in proportion. So let me look. All three pairs of sides are proportional. And when we talk about proportional, it's simply this fraction here, right? HL over JL, right? So we need all three sides. Sorry, I didn't like how I wrote that. Proportional. So basically we need for SSS theorem to be true, we need all three sides of the triangle to be proportional. Three pairs of sides proportional. So if I have here HL, which is this length here, over JL, which is this length here, equals IL, which is this length here, and KL, which is this length here, my last missing side is obviously these two sides, right? These two sides here, they have to be proportional, which means in this case here, I can write my answer as I need this side here is equal to this side in proportion, right? It's proportional to this side. So I can say that HI over JK is also proportional for triangle HLI and triangle JLK to be similar through side theorem. Remember, so this here is our answer. So this here is our answer here. This is HI over JK. So let's look at this answer here. It says two triangles are to be similar if their corresponding sides are proportional and the corresponding angles are equal. That is, their corresponding sides are in the same ratio. So this is the ratio, right? HL over JL or whatever. Because I have this triangle, this length here and this length here are proportional in size, right? So since we have triangle HLI similar to JLK, therefore this implies that angle H equals angle J, angle L equals angle L, and angle I equals angle K. So they actually even broke it down even further, and they even talked about angles, right? So they said that angle J here, angle J is equal to angle H, angle L is equal to angle L, angle K is equal to angle I. So therefore, they wrote this here, right? And because this here equals HL over JL equals LIL over KL, therefore it also equals HI over JK, which is exactly what I wrote here. So they actually proved this even further with using angles, because remember, if you have this two sides that are similar in length, they also equal to angle, right? So in terms of if two sides are proportional to each other, then you will also get a same angle between those things. So between those two sides. So this here is a great solution and analysis.